Okay, yeah, let's go for it. Let me know when we're live. Awesome. Hello, everyone. It's great to be here virtually in Tennessee, although physically here in Berlin. It's 8:30 p.m. here. It's dark, it's cold, it's miserable, but I am happy to be with all of y'all, at least virtually. So, yeah, today I'm going to talk about Jina AI, about AI-powered search, and give you a quick walkthrough of how you can build your own meme search engine using our cool, well, I say cool, I work for Jina, of course I'm going to say cool, but using our open source framework. Without further ado, I'll start sharing my screen and we'll jump right in. All right, so let's open this baby up. If you have any questions, feel free to ask in the channel. Feel free to butt in. I'm down for that. Yeah. And yeah, just go for it. So yeah, I'm talking about Jina and neural search, as I already said. I'm Alex CG. CG because I have an incredibly long, ridiculous name. Thank you, parents. I'm the developer relations lead for Jina AI. So I don't develop the project directly, but I make it cool and attractive to other developers in the wider world. So I get them to use our cool stuff. Quick content warning, there are going to be animals ahead. Some of them are cute, some of them are really not so cute. You have been warned. Before we dive into what AI-powered search is or what neural search is, let's just step back a little bit and think about, what the heck is search anyway? So normally when we think of search, we think of a boring old white text box on the screen, typity-type in, text out, right? That's pretty much the same with Twitter, Google, Stack Overflow, yada, yada, yada. You know the drill. But search could be for a lot more things. I mean, the App Store is a common one, obviously. Again, text in, stuff with text coming out. But you could also think about Shazam. You upload a Beyonce song or a Lil Nas song and you get similar songs back. Or, you could upload a video file and get similar video files back. Ask a library of deep learning papers any question, or upload a PDF and find similar PDFs. Or even just a chatbot search. Instead of getting loads of results back, you're typically getting just one result back. A lot of these things, they're dealing with similarity search, right? You're uploading one thing and it's finding things that are very similar. And that's pretty much what neural search is all about. Give the search engine a thing, it'll find similar things. Upload your favorite pair of sneakers to the fashion store, or a picture of your favorite sneakers, and it'll find similar sneakers. So there's a lot you can do with it. To explain neural search and how it works, let's just look at some cute pictures first of all. So obviously we've got some cute puppies, some really cute kittens, totally adorable, right? And now let's do something really kind of boring with these cuties. Let's put them on a graph because, yay, everybody loves math, right? So we've only got one axis. They're all equally cute, so we can't really rank them by that. I mean, you could say they're not all equally cute, but hey, fight me. I think they are. So we can basically rate them on a cattiness to dogginess scale. And these are all equally doggy, these are all equally catty. I only spaced them out so we get to look at all of them in all their glory. And now, yeah, I'm really sorry about this, people, but I did warn you. We're going to look at some nasty pictures of other animals. Yeah, they're definitely cats, or cat-like things, and that's definitely a dog. I have been told that this other thing with the bulgy red eyes is a dog. I have not been to hell, so I can't claim it looks more like a demon, but yeah, I have my doubts. Now if we put them on a graph, we have a whole other axis to work with. We've got cat, dog, we've got and ah. So yeah, we've made the graph a little more complex. We've added, well, we call it a dimension. So here we have the cute, scary dimension, and here we have the cat, dog dimension. And these are common terms in deep learning or machine learning, because a lot of deep learning and machine learning deals with graphs and stuff like that. And each of these points we call an embedding. So it's the point on a graph where a piece of data fits. We have two axes or two dimensions, so we have two numbers in the graph. And often in a real-world deep learning context, you'd be dealing with hundreds of different dimensions, not just two, but it's kind of difficult to do more than two on a two-dimensional screen. All of this together, we can call it the index. And now, like I said, let's do some similarity search. We'll get a new image and find something that looks similar. And, we've got this really cute, fuzzy little snowball guy here, or gal, or it's a dog. The dog can choose, I'm not going to go into that. But where would this snowball fit? I mean, we look at this. We know. We're humans. We get this. It's kind of simple. The snowball would fit right around here. Right around the other cute, fuzzy little snowball. So yeah, we found the closest match. Or another way to say it would be the nearest neighbor. And that's a really common phrase in deep learning. So how did we do it? I mean, yeah, come on. It's just images of cats and dogs, bruh. How dumb do you think we are? But, we can do this because we've seen loads of cats and dogs before. We've grown up around them. We've seen them on TV everywhere. So we have a mental model and we can embed the pictures into it. It's like if you've never seen Star Trek, you wouldn't know how to categorize a Klingon or a Vulcan. Or if you hadn't seen... okay, I'm grasping at straws here. Yeah, my pop culture runs out about 20 years ago. You can tell by the beard. But you get the picture. Without knowledge of this domain, you can't really build a mental model. So in deep learning, we could do this because we were trained to do it. Maybe not formally trained, but the environment, quote unquote, trained us. And that's what we have to do to deep learning models. Actually, that's not what Jina is about. We use pre-trained models. So there's a whole bunch of stuff out there. The work's already been done. It's already open source. But yeah, so the whole reason we did it was to show that the lump of meat in our head, our meat-based neural network, which is what it is, neurons and synapses, operates in a very, very similar way to if you're doing it in silicon. Neural search uses embeddings from deep learning models for similarity search. So just bringing back a few of the definitions from earlier there. In reality, as I said, these models are using hundreds of dimensions to understand data and create embeddings. It's difficult to show on a screen. And, we could add a whole bunch of different dimensions to our models. How floppy are the ears? What color is it? Is it dark or light? I mean, with that, you could do one dimension. If you want to go, is it yellow or brown or black? You could use 3 dimensions, one for R, one for red, one for green, one for blue, and so on and so on. So this is what we call neural search. The advantage is that it's semantic and that it actually understands the meaning. When you look at a cat or a dog, you're not looking at the shape of its ears and going, oh yes, it has pointier ears, not floppier ears. That's a cat. You're looking at the whole thing holistically. You understand what a cat is. Just like a neural network would understand what different words mean, like red or scarlet or crimson. It would get that they're all the same thing because it's been trained on a whole bunch of data. It works with all data types. Or I should say all data types a neural network can understand. And neural networks can understand a whole bunch of stuff. And I'll go into those a bit later. And there are loads of different modules you can plug and play out because, like I said, a whole bunch of different neural networks. It's kind of a pain in the neck because actually deploying this stuff, if you've done any deep learning or machine learning before, you'll know that it's cutting edge. It's often cutting edge. And so it has a lot of complex dependencies, both in like the package versions and the version of the language. Like if I want to run one module that needs TensorFlow 1.3 and Python 3.7, and I want to use another one that needs TensorFlow 2.1 and Python 3.9, they are really not going to play ball very well. I mean, you could use virtual environments, but it's not going to be a walk in the park. So actually connecting these things together and building something that scales out, like on Docker, on Kubernetes, running on different servers all around the world, that's what Jina, our product, helps to solve. So our mission is to provide an open source neural search ecosystem, yada, 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 corporate jargon stuff. Yeah, we let you build a search engine for any kind of data. And after you finish building it on your own machine, you can get it going on the cloud. We've got stuff on AWS, on Google Cloud Platform. We're not a search engine, we're a search framework. So we let you build your search engine. That's the key thing. So with Jina, you can search any kind of data that a neural network can understand. We've got a selection here. There are demos online of many of them. Some of them, there are examples in GitHub repos like the protein search. There's a project searching amino acids for drug discovery. If you go to where are we? Showcase.jina.ai. We have several examples, so you can ask a paper anything. What is machine learning? Hope it's not down. So these papers contain answers to that question. I will say that these are relatively simple examples. In the real world, you'd have a massive, massive data set. This is just to show the basic idea. So these will not be perfect. We've got an e-commerce search. So you could say, find me some sneakers. It'll search. And it's finding similar pairs of sneakers. Or mostly similar. I mean, this should probably be higher than that. But they're not perfect yet. And the way this is working is we're using an image model, an image neural network called CLIP, which I think was developed by Facebook or Google, a big company, but open source. And it's looking at the picture and it looks at the different shapes, like you would with your own eyes. It connects the dots and it sees, oh yes, these are sneakers. And it knows that these are also sneakers because it's looked at these pictures and has been trained on sneakers or dresses or t-shirts or other fashion items. The one I really like is the gaming one because this is something I have never really seen in the real world before. So this is a search engine for game developers. If you're building a game, you know, let's say you're building a first-person shooter. You need goodies, you need baddies, bang, bang, gun, gun. So yeah, you need 3D assets to play with. And these look kind of dull, but if you start dragging them around, you'll see we've got a baseball cap. We can find similar, stop that, I need to have a... So it'll find similar things, similar shapes. We've got some hats. We've got a lovely vase. I mean, it's round. You could... Yeah, that's not a perfect result. We've got a... Come on, darling. We've got a piano. It'll find similar things to that. Okay, I really need to have a word with our team. So the cool thing about this is, I mean, it's more a front-end thing than actual Jina, but if you use this on your phone, it'll project these 3D models into the real world, and you can rotate them, you can zoom in, zoom out. They're kind of cute. And we've got some kind of a gun as well. And yeah, of course, this will bring up other guns. So yeah, similarity search. These find similar things. I will show you an example of the text search in a little while, because that's what we'll be very quickly going over. Jina has 3 basic concepts you need to learn. If you want to build a search engine, you have documents. They're the thing you put in and you get out. So if you want to search images, you put images in. Maybe you use an image to search for similar images. Those are all documents. An executor does a simple thing. Like maybe it'll detect the objects in an image, or it'll break a text into sentences. And if you want to perform a high-level task, you connect a lot of small-level tasks in life and in Jina. So we call the higher-level task a flow. And this would be like building a database of the images you want to search. So building the index would be one flow, and then actually searching the index would be another flow. Because if you look at a search engine like Google, it rebuilds the index, and it doesn't rebuild the index every time someone searches. It rebuilds the index not very often, because that takes a lot of computation, takes a lot of time. Whereas searching, it's got to be fast, it's got to be quick. So yeah, in short, all of this, you only need a few lines of code to build a search engine. I've done it in about 40 lines of code using Jina. You can search any kind of data, scale up, 3 simple concepts, and yeah, pretty straightforward when you understand the design pattern. And now how are we doing on time? We've got 12 minutes. Okay, we're going to blast through this thing. So we are going to go over the meme search example. So this is an example I built myself a little while ago. Ooh, dark mode, I didn't even know we had this. So this lets you input some text and it'll find memes with similar text. So actually in our example, we're finding memes that relate to Winnie the Pooh and to food. So we can type in Pooh food. And I really wish I'd thought of how this sounds before I had used it as an example. Pooh food is not a nice term. Sorry, people. But yes, we can find, it's looking at the name of the template, Winnie the Pooh, and it's finding similar words to food. So top result actually has the word food. But the other results, they don't have the word food. They have words like breakfast, soup, eating, ingesting, meat. Ooh, meat Twinkies. I will not sleep well at night tonight. So the model we're using, it actually understands the meaning and kind of the network of words. It understands. Part of me wants to do air quotes, but it understands in pretty much the same way we understand that breakfast is food, soup is food, and so on. Let's walk through the code. We've got a Colab notebook. Hang on, I'll pop into Discord and try to share it on the channel. All right, so you can go straight to the notebook yourself. So yeah, we are going to essentially rebuild this. So just to be clear, we're not searching using an image, we're searching using text. And we're using that text to find a set of matching memes. So first of all, we're just going to search 50 memes, because as I said, indexing takes quite a lot of time. And we have 10 minutes, man. We do not have that time. We're going to run this anyway, because why wouldn't you trust me? Strange old man with a beard. I mean, you trust Santa, so... All right, we are going to... Google Colab doesn't store state, so we have to pull the requirements from somewhere else, and then we'll install them using pip. All of this code is in Python. If you're doing machine learning or deep learning, it's very likely you're using Python. Maybe you're using R, but most of the big libraries, most of the stuff is done in Python. It does take a little while to install, but we are quite lightweight compared to other deep learning frameworks. Just another word on the programming language. Jina provides the back end. So yeah, if you want to write your own front end, obviously probably do that in HTML, CSS, JavaScript, the usual stuff. Though the front end I use is a framework called Streamlit because I suck at JavaScript. So we're going to download the dataset now. This is an open source dataset of memes. I really like this one because it has super rich metadata. Because if you're just getting a whole bunch of images, you don't quite know what you're getting. I did a lot of research into this. Not fun. So it has metadata. You can look at the images and you just know they're memes. They're in the meme format. There's no horrible, mean memes in there that I've found. I had to search all the bad words, and I didn't want to, but I was relieved there was nothing bad, or nothing too awful, compared to all the other data sets out there. And it's memes that people will actually recognize, that you've probably seen before. It kind of sucks because, memes are changing all the time, and getting a good data set, those do not come along. So it's going to be a little out of date. So let's make a data directory, and then we'll get the JSON file of the memes. So now we're going to load this data. So the structure of the file is, it's a list of meme templates, like Winnie the Pooh, like Drake and Hotline Bling, or The Most Interesting Man in the World, and so on. We'll shuffle them. We'll create a document for each meme, as I said before. We're going to put that document in a document array. Set the document text to, so these variables are in the JSON. So we've got the template name, like surprised koala, and the meme caption, like this is poisonous. What? And then we'll populate some metadata for the document, like the URL for the image, because the URL is in the metadata. We don't need to store all these images on our own machine. Okay, yeah. So we'll do the imports. And when you're doing any kind of deep learning or machine learning, working with data sets, you have to load a whole lot of data. And every time you need a different way to do it because data sets are never connected. So this is not super important. I'm going to skip a few things. Why do we need to shuffle? Did I shuffle that? Yes, I did. So let's just see the images we've got. Okay. Hang on. Okay, I'll do this one. So as a sample, yeah, we've got a whole bunch of different images. These are shuffled, otherwise we're going to get a very boring data set to search. Now let's build up our flow. Are there any questions so far? Because I realize I'm really running over time. Okay, so as I said before, we have executors. These do simple things to the inputs. So it encodes them into vectors and puts them on the graph, as I said before. And it builds an index. So it turns them into numbers, it puts the numbers on the graph. Similar things on the graph are closer together. Like with cute cats and ugly dogs. Though no dog is ugly deep down. Let's index the data. So we're going to open the flow, give it the input documents, and just give it a small request size, 64. So it'll take a batch of 64 documents at a time. So right now we're getting the encoder from Jina Hub. You could build your own encoder. That will take a lot of time, especially for me because I'm no deep learning expert. But yeah, Jina Hub gives you a whole catalog of different executors you can use, the different modules to do different things to your documents. Because maybe you only want to search paragraphs, or you only want to search parts of images, or whatever. So we've got a whole bunch there. Right. Okay, we are waiting for that to be ready. I'm just going to go back to the Discord and check for questions because I realize we're super running low on time. Okay, I don't see any so far. Cool, we've indexed all those documents. Now we'll search through the documents, search through the memes. So we're going to feed in another document. So we had this flow. We're going to use the same flow for both indexing and searching. So first of all, we've got one document. We're going to use this word school just to search for memes about school. And then we'll pass that into the flow. So this time we're using flow search, not flow index. So flow index builds up the whole index of the data set we're working with, like cute puppies or cute kittens, or all these different memes. And then flow search takes one document and finds the closest one in that index. The first time round, we took that little cute puppy, and this time round, we're just taking the word school. And this is a lot quicker because we're only dealing with one document now. Dumpty dumpty dum. Oh, that is disappointing. Oh, the demo effect in action, isn't it? Happens every time. Happens to the best of us. So it is not going to work tonight, folks. I am sorry. I could go in and fix this, but we have 2 minutes left. The way I would fix it is by upgrading my version of Jina. Because mine is a little out of date. We can pretend we're all in a happy cloudland with rainbows and unicorns. Yes, everyone's happy. Cool. All right. I'll stop sharing my screen. Where am I? Always happy to hear them. Well, that's 1 for 1, with 1 all. It's a tie for mess ups. All right. Well, it's great speaking to you all. Yeah, if you have any questions, feel free to ask in the Discord channel. One of our people will get back to you. So my team are here in Berlin, and yeah, it's really late in India. It's getting late here. But yeah, we'll be around to answer things probably. Oh, thank you. I should be applauding all of you. Yep, go to the GitHub repo, and that's the place to find out more. The website is more corporate-y, so GitHub is the place to be. All right. Yep. Yeah, the notebook is in the channel, and there's a link in the notebook to the repo. Perfect. Thank you. Have a great day, everyone. Ciao.